All right, welcome to the final sections of what we're going to be doing for this class. We are focusing on trig equations. So we're going to start off with our first example here. Hopefully you've read the notes so far and you have them in front of you and you're looking on as we go. So when we are doing these, keep in mind you're just solving 2-step, 3-step equations or whatever else. The only difference is that you have a sine, a cosine, a tangent, whatever. Also, keep your unit circle handy too, okay? So what we're going to focus on today on this one is finding all solutions of a trig equation with just a single variable. So we're looking at just sine of x or just cosine of x or anything else. So on this one, our problem is solve our problem is solve sine. Let's try this one more time. Our problem is solve 3 sine x minus 2 equals 5 sine x minus 1. So we are going to treat this just like a normal equation. This all goes together and this all goes together. This minus 2 and that minus 1 are not attached to the x. The only time that minus 2 or minus 1 is attached to an x is if it's in parentheses. Otherwise, it's not. So first thing we're going to do is we're just going to go ahead and we're going to move all these signs to one side and everything else to the other side. So I'm going to go ahead and I'm going to add this 2 to this side. I'm going to subtract that 5 sine x and move it to the other side. That leaves me with negative 2 sine of x is equal to a positive 1. Okay, so now I've got negative 2 sine x equals 1. I need to get the sine x by itself, so I'm going to divide both sides by that negative 2, and I wind up with sine of x is equal to negative 1 over 2. So I want to know where on my unit circle is my sine negative. Well, you know that sine is negative in quadrants 3 and in quadrant 4. When you do this, unless they give it to you in degrees, you want to wind up doing this in radian form. So where is my sine of x negative 1/2 at? It's going to be negative at 7 pi over 6. And it's going to be negative at 11 pi over 6. So this is when I'm bounded between 0 and 2 pi. This would be my answer. But notice how it says I want to find all my solutions. So when you do this, you know that the period of a sine is 2 pi. So when we focus on this, we turn around and say, okay, if I'm bounded here, then this is my answer. But if I'm not bounded and it wants to know all solutions, then all I'm going to do for my all solutions is I'm going to take my first answer and I'm going to add 2 pi n. And then I'm going to take my second answer and do the same thing. 2 pi n. And I kind of made a mistake. I don't know why I wrote a 2 there, because that should be a 6, so my bad. So when you're doing this, this piece right here will generate all your solutions for this answer. Your n is how many times have you gone around the circle. So on the first one, on this one right here, we haven't gone around the circle yet, so your n is 0. But if I go around the circle again, then I'm going to have 7 pi over 6 plus 2 pi because my n is 1. And then I'll get an answer for that. And you want to keep everything in terms of pi. And the same thing down here, I'll do 11 pi over 6 and I'll add another 2 pi. If I go around again, that 2 pi turns to a 4 pi because my n will be a 2 because it'll be the second time around, and so on and so on and so on. Okay? I hope that clears that up a little bit. Let's move on to example 2. TTFN. Ta-ta for now. All right, welcome back to example 2. Now, going forward, you're not going to have the easy equations like sine of x, tangent of x, things like that. You're going to have tangent of 3x. You're going to have sine of 4x. You're going to have those type of things, and you're going to have to apply all your knowledge from the past and some, some thinking skills in order to be able to solve these. So looking at our first example here, and this might go into a second video, it depends. Mind you, I've only got a 10-second limit. Or, I'm sorry, 5-minute limit. So we're going to start off with tangent of 3x equals 1. So the thing you need to remember about tangent is that the period of tangent and cotangent, the period is pi. So like with sine and cosecant and secant, their periods are 2 pi. Okay? But here, your period is going to be 5. So instead of when you're trying to find all the solutions, you're going to find all the solutions, but it's going to be based off of that piece right there. Okay? Now, let's go ahead and bound this to make our life a little bit simpler in the beginning. We're going to be bounded between 0 and 2 pi, and that's it. So what we're going to do first is the period of your tangent function is pi, which I've said. So that means when we start focusing on this, the first thing I want to focus on is only on the interval from 0 to pi, because that's the first period that we're looking at. And I want to know, where is the first time I see my tangent function equaling to 1 at? So if you have your unit circle in front of you or that chart in front of you, you're going to go down the tangent column, and the very first time you see 1 in that column, you should look over and you wind up seeing pi over 4. So this is what we know. If we know that at pi over 4, my tan of x is equal to 1. But my question is 3x, not regular x. So what I have to do is I have to adjust for that. Okay? So that means if tan of x is equal to 1 and tan of 3x is equal to 1, then we know that where they're both located at is going to be at pi over 4. So I'm going to come over here and say, okay, I've got 3x is going to be equal to pi over 4, because that's what my 1 is. My 1 is going to wind up being pi over 4. And then I'm going to solve this piece here for x. Now, what I need to know and what I need to do on this one before I do that is I'm going to go ahead and put plus n times pi, because I want to know how many times or how many periods I need to go through in order to get all my numbers that are in that 0 to 2 pi range. Okay, so looking at this, I know that I've got this 3x sitting here, and then it equals pi over 4 plus n over pi. I need to solve this for x, so I'm going to divide everything by 3. When I do that, I wind up with an x, and I have pi over 12 plus n pi divided by 3. That is your general solution. That will generate every single number that you need in that specific part to be able to find that answer. Okay? Now, here comes the fun part. We need to know where this x is going to be true at. So when we're doing this, we're going to keep plugging in values for this n value right here until we get an answer that is greater than 2 pi. All right? Because that's our boundary. That's our upper boundary. So I'm going to stop here and pick up in the second video. So go ahead and see if you can figure out the next ones. And if not, we'll go from there. I'll see you in a few seconds. Ta-ta for now. All right, welcome back. So now that we have solved for our general equation, what we're going to do is we're going to generate all the possible answers that we're going to have that's going to be between 0 and 2 pi up here. Okay, my recommendation is make a table. what we are looking for when we go through this is we want this answer over here to always be less than 2 pi. The moment we go over 2 pi, we're done. That means all the answers before it are going to be our answers. Okay, so you're going to have multiple answers on these. So now, I started off with my initial answer, which was pi over 12. That's why I didn't go anywhere. My initial answer starts with a 0, so n equals 0. When I plug in into this, basically this part right here, I get 0. That only leaves me the pi over 12. So now we're going to go to 1. So my n is 1. That means that this is going to wind up being pi over 3. And I'm going to add my pi over 3 to my pi over 12. And when I do that, I get 5 pi over 12. I'm still less than 2 pi, so I keep going. 2. This gives me 2 pi over 3. I'm going to go ahead and plug this in again. I get pi over 12 plus 2 pi over 3. And when I do that, I get 9 pi over 12, which reduces down to 3 pi over 4. I'm still less than 2 pi. You're going to keep going. And you're going to keep going until you get a number that is bigger than 2 pi because that is your upper boundary. I plug in 3. I get pi. When I do that, I wind up with 13 pi over 12. I go to 4. I get 4 pi over 3. And when I do that, I wind up with 17 pi over 12. So I'm still less than 2 pi. So then I go to 5. I get 5 pi over 3. When I do that, I get 21 pi over 12, which reduces down to 7 pi over 4. When I go to 6, I get 2 pi. And then when I wind up doing that, I wind up with a 25 pi over 12. So here's my problem. I'm at 25 over 12. This number here is bigger than 2 pi, so I cannot use any of this. So my answers is that one, that one, that one, that one, that one, and that one. Those are all the solutions that are bounded between 0 and 2 pi for when I give you the equation of tan 3x equals 1. So you will have multiple solutions in on this, okay? And if you have your calculator, I would suggest you plugging this into the calculator so you can actually see what it looks like and know that you're going to have multiple solutions. So I don't know if I actually downloaded that on this. Let me see real quick. Did I put the calculator on this one? I don't think I put the calculator on this one. All right. So when you get your calculator, what you're going to do is you're going to type in up here on Y1, you're going to type this piece into Y1. Then you'll type this piece into Y2. Go to your screen settings for your X values, and you're going to set this as your X min, and you'll set that as your X max. Okay? And then you're going to hit the graph button. And what's going to happen, it's going to graph all of this. And so when you do that and you count, because what you're going to do is once you go through this and you see where that x equal or that y equals 1 intersects all the other ones, you're going to count how many you should have in there. And when you do that, you should wind up with 1, 2, 3, 4, 5, 6 different intersections. And those numbers that they're intersecting at is this piece right there. Okay? I hope that makes a little bit more sense. If not, make sure you're emailing me and texting me and things, and I can answer those questions for you. Going on an example. All right, welcome back. We are on example 3, so almost done with all these examples, okay? So what we're going to look at today is solving a trig equation in quadratic form. So that means now instead of just having like the sine of x or the sine of 4x or vice versa, or whatever else, now you're going to have sine squared of x, plus 3 sine of x, so on and so forth. So you're actually going to have a quadratic equation in a way. So you need to keep that mentality when going into this. One of the ways to do this when you're focused on a problem like this is not deal with the cosines or sines or tangents or whatever they give you. So the first thing I want you to do is I want you to remember use substitution. So what we're going to do is we're going to let, that is not let, I'm not really sure what that was. We're going to let cosine of x equal u. That means cosine squared of x is equal to u squared. Okay? So now we come over here, and instead of writing the 2 cosine squared x blah 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 and getting really confused and everything, we're going to come over here and go 2 u squared plus u minus 1 is equal to 0. And then we're going to just solve this quadratic equation. Now you have multiples of different ways of solving the quadratic equation. You can do it with a quadratic formula or whatever else. I'm going to leave that up to you. But for time's sake, I'm going to assume you know how to solve a quadratic equation. So when I do this, I wind up with 2u minus 1 and u plus 1, and that equals 0. Now, I need to substitute my u back in. So what I do is I come over here and I say instead of 2u minus 1, I'm going to say 2 cosine of x minus 1 times cosine of x plus 1, and that's all equal to 0. So now, because it's a quadratic, we're going to break this up and set each piece equal to 0 so I can find all of my answers. So my first one is 2 cosine x minus 1 is equal to 0. And my next one is cosine of x plus 1 is equal to 0. We're going to solve this one on this side first. So I'm going to move the negative 1 over. That gives me cosine of x is equal to 1. That means cosine of x is equal to 1/2. When I do this one over here, I wind up with cosine of x is equal to negative 1. Now, back to the unit circle. Everything goes back to the unit circle. We know that we are bounded between 0 and 2 pi, so we're going to start with the left side first. Where is your cosine going to be equal to 1/2 at? Well, first off, cosine's positive in quadrant 1 and quadrant 4, so that's going to be your first thing. And then you're just going to go and look at your unit circle, go down your chart or however you want to look at it, and find out where that cosine of 1/2 is. And when you do that, you wind up with pi over 3 and 5 pi over 3. On the second equation on this side, where is my cosine equal to negative 1 at? There's only one place for that one, and that's going to be at pi. So my final answer is pi over 3, pi, and 5 pi over 3. And that's how you solve a quadratic equation in our trigonometric equation in quadratic form. Okay? Remember, if you feel comfortable and you want to do it this way, go for that. That way you're not having to deal with all those sines and cosines and getting confused and everything. It's actually a lot easier because you know how to do that. If you don't want to change it out and you're worried about moving things around too much, then go for it. Go straight ahead and just try not to get yourself too confused, okay? Again, if you have questions, make sure you're sending me text messages and reminds and everything else, and that way I can help you out. So I think there's one more video after this, so I will see you in a few. TTFN. Ta-ta for now.